The Geological Society of America, or GSA, hosts dozens of field trips every year, mostly in the US, but some internationally. Guided by local geology experts, these field trips are perfect for participants of all backgrounds, whether you're a professional, a student, or just a geo enthusiast. And I recently got to interview the field trip leaders for the upcoming field trip to the Jurassic Park of Connecticut, so hopefully it can provide some insider information as to how this trip will go and what participants can expect. So let's get into it.
My name is Peter Drzwicki. I'm a professor of geology at Eastern Connecticut State University, specializing in sedimentology. And I wanted to run this trip because I've been going there for almost 20 years now with students, looking at the story they tell at Dinosaur State Park and looking at the rocks and coming up with a slightly different interpretation. So I began to work in the area and try to give you my interpretation of what I think is going on, and I wanted to share that with the field trip participants.
So my name is Michael Ross. I am the Environmental Education Coordinator for Connecticut State Parks, and I'm stationed at Dinosaur State Park. So that's my primary responsibility. But I do run several other educational programs around the state park system. One of the reasons that I wanted to have this field trip also is to help everyone to become more aware of the dinosaur tracks in Connecticut, also our preservation efforts and the immense potential that Dinosaur State Park has for further research. And we can talk a little bit more about that later.
My name's Drew Hyatt, and I'm also in the Department of Environmental Earth Science at Eastern, a colleague of Peter's. In fact, he initiated the effort on the field trip, invited me along, and I've used it. I'm actually a geomorphologist, not a paleontologist or sedimentologist, and I have used the park to learn how to do very detailed three-dimensional modeling, and as well to involve students in undergraduate research at that site and other ones.
Amazing. So, very diverse expertise coming together to run this trip. I love that. That will mean that the participants will get a lot of really cool perspectives, which is always what we're looking for with GSA field trips. So before we really get into the details of this trip, the trip is, titled Connecticut's Jurassic Park. And so I was curious, what makes this Connecticut's Jurassic Park? Me and my viewers are assuming it has something to do with dinosaurs, but what kind of dinosaur fossils are preserved here?
So, dinosaur tracks have been well known in the central Connecticut Valley for a long time, more than 100 years. Even the indigenous peoples were aware of them. In 1966, they were digging the foundation for a state laboratory for the DOT. And one of the excavator operators, his name was Ed McCarthy, he flipped over a piece of rock, and underneath that slab of rock, he found several what he knew to be dinosaur tracks. He didn't know what kind. So he went to tell his supervisors and the architect, and over the next several weeks and months, they actually did stop the construction at that point, and they discovered over 1,800 tracks at Dinosaur State Park. And so it was one of the quickest state parks that came about. And so today, we have over 750 dinosaur tracks on display. The rest of the dinosaur tracks had to be reburied in 1976 to preserve them because there wasn't enough state funding at that time to build a building over all of them. And so normally when you think about seeing dinosaur tracks, you think about going out west and having to travel 3 hours on a dusty road, and then you can spend an hour or two there, and then you got to get back before it turns into nighttime. And at Dinosaur State Park, though, it's about 2 minutes off of Interstate 91 in the middle of Connecticut, and it's one of the busiest travel corridors in the country. These dinosaur tracks are from the earlier Jurassic, late Triassic, and so that's primarily why we are basically the Jurassic Park of this area.
These tracks were deposited in a very interesting age in the evolution of dinosaurs. So dinosaurs evolved in the Triassic period, but they shared the terrestrial environment with other groups of reptiles, and they weren't really dominant. And then when Pangea started to rift apart, there were these great volcanic events known as the Central Atlantic Magmatic Province, and it really altered the climate and resulted in a mass extinction, of which the dinosaurs emerged as the dominant species. So from there on in, they became the dominant terrestrial species. And Dinosaur State Park is actually right at that earliest stage, capturing the just the moment that dinosaurs were kind of coming into this dominance. From there, their story really began.
Oh, okay. I'm glad you mentioned that. I have another video where I talk about the Triassic mass extinction and how
Yeah.
the dinosaurs became dominant after that. But yeah, no, that's such a great like little window of time to get to see into that, because it's always like it makes you wonder, because mammals and dinosaurs evolved in geologic time not that different from one another. To my understanding, it's like dinosaurs, then a few million years later mammals potentially. And so it just makes you wonder, like, if mammals had had that slight head start, could they have become the dominant ones? I don't know, but it's a really, really cool thing. And also the fact that a mass extinction led to more success for the dinosaurs is like an interesting concept. So, yeah, definitely a really cool snapshot of time.
They did not survive the next mass
That's
extinction.
true. They
Except the
had to
bird.
go some, but they lived for like 200 million years or more. Also, before we started recording, we talked about how, some of these tracks have different names than dinosaur names, and they may be theropods, but we're not actually sure. So, like, can you break that down? Why is that? What are these? What do we think they might be?
The tracks at Dinosaur State Park are almost exclusively what we call Eubrontes tracks. They're tridactyl, meaning they have three toes, and they are interpreted by most people to represent theropod dinosaurs. But we don't actually give a dinosaur name to the tracks because we don't really know who made them. We weren't there at the time. So we have to give it our best guess. And they keep the track names separate from the dinosaur names so that if they change their mind about who made them, you don't have to go and change all the literature. But these tracks are ascribed mostly to the dinosaur Dilophosaurus, and that's because that was the only theropod large enough to make these tracks that we know of in the United States. The skeletons are found out west, but we don't know of any other dinosaur at that time that was large enough to make tracks the size of Eubrontes.
Yeah, no, actually, we had a viewer when I prompted viewers for questions, they mentioned that dinosaur, but I had no clue, the context. So that actually they must know a thing or two. That's awesome. And so, we'll get a little bit more into where they were deposited and what these dinosaurs are. But before we do that, can you just explain, kind of walk us through what participants might get to experience on this field trip? And is it something that non-experts can join?
This is a field trip that anyone can join. You can actually come on the field trip without even registering for the meeting it's associated with. And the park is great. It's a public area that is designed for people with no background, basically. So the signage is there, the displays are there, and it's a great like natural laboratory for learning about how dinosaur tracks are made and preserved, and what they can tell us about the dinosaurs that live there.
As a non-specialist with looking at dinosaur tracks, it's the first time I've ever been on a track site, and it's just totally cool. And the participants are going to get to walk on the track site. There is a viewing platform, but some of the really cool stuff is actually under the walkway or portions of it. And there are so many tracks that it's just very different from something that you might have done before. There are actually a few features that are still not known for sure what they are, and we'll get a chance to see them. My role is largely going to be trying to describe how you can make extremely detailed maps, topographic features, 3D prints, whatever you want, from any kind of physical object. And that came from learning a variety of techniques in photogrammetry and laser scanning that we've used at the site. And so we'll get to look at those, and I'll describe a little bit how that's done. I won't go into a lot of gory details, but it's applicable to many different topics. And what's interesting at Dinosaur State Park is it's a super cool site to map, but it's also quite challenging because it's set up for people viewing the tracks, and so it's got some lighting that enhances it, but actually makes it very difficult in some cases to model. So if any participants have done that, there are a few tricks that really help that to work out well, and we'll have lots of examples.
Actually, on that, we had a lot of viewer questions about, like, what kind of environment were these rocks deposited in? And, Drew, you've said you've mapped this place up and down. So kind of what has come out of all this mapping? Like, what have we learned about the general context of the area?
A lot of the work that I've done is more focused specifically on the mapping. I do worked with Peter quite a bit, and also part of the reason why I got involved in the first place, James Farlow, who is published widely on track sites all over the world. And so what I do is I create models that enable people like Jim, to measure certain positions on a track, and then you can use those distances and positions to infer who the track maker was. And because he's done this all over the world, he has a huge database. And so the cool thing with the three-dimensional modeling is that once we build the entire track, I can also tie it into his database. So he kind of focuses on the tracks. Peter has more to say on the environments inferred from the characteristics. So I turn it over to him on that part.
When these tracks are first described, a couple of the layers that they're found on have some nice symmetric ripples, which usually form under shallow water conditions. And so it was interpreted as being a shallow lake environment. And it still is a lake environment or lacustrine environment, as we like to call it. But there's a lot of debate as to what volume of water was there. We can look at the sedimentary structures, and to me, they look like it was a lot drier than people think. So more of an ephemeral lake, a lake that comes when it rains and then dries up. I think what we can say for sure is that at times the water was maybe up to a meter deep, and at other times it would dry it up because we have thin little layers with mud cracks on them and raindrop imprints. But there's a lot of debate as to what was actually happening at the exact time the tracks were registered. And so that also then spills over into a debate about what the dinosaurs were doing there. But I think it's by looking carefully at the sedimentary structures and the rock types that we can start to figure out a possible environment or range of environments that these dinosaurs were inhabiting.
Okay, so potentially shallow lacustrine, sometimes less lacustrine, sometimes more. And so you mentioned before we got started that, the dinosaur tracks are kind of, there's no big trend in direction and like there's some different orientation. So like what do we think they were up to? How do we interpret them as of now?
The way that we interpret it, and of course this is open for debate, and it's even been debated among the three of us also on what's happening here, just because we don't know, and there's a lot of information to gather and to process. But it appears that there was an individual or several individuals or a small group that would come here periodically throughout the year. And we believe that they would come when the water was a little bit deeper relatively, potentially hunting, fishing. And in the past, supposedly there was a fish fossil that was found on site. And so that kind of gives some evidence towards that. We don't know what happened to that fossil, but it was reported that there was one found here at one point. And there's other evidence to suggest too that these animals were not running to catch prey or running away from prey, because when we do calculations on the potential size of these animals, they could be traveling a lot faster than what we estimate their speed to be. And there's some debate about how to estimate that speed right now. But if we go with that traditional understanding, then they were walking pretty slow. And if we think about the animal that is alive today that's most analogous to bipedal dinosaurs, which would be birds, when birds fish, we know that they're very deliberate, they're very slow, not wanting to scare the fish away, and then they strike for the attack. So it would make sense that these dinosaurs, if they in fact were fishing, then they would be going slow as well.
And there's also recent work has shown evidence of there being a microbial mat that developed on the surface that has the most tracks. And that has several implications. Number one, a microbial mats can form in a lot of environments. The most common ones today are tidal flats and ephemeral lakes because they tend to form in places where there's no grazing organisms to eat them.
That's actually really interesting because all the pieces that you've mentioned seem to me, I just visited the Great Salt Lake in Utah, and it was very much, I mean, you had your dinosaurs, your birds, well, not fishing, but like eating, I assume the shrimp and things, the salt shrimp, but they were kind of like walking knee high in the water slowly, looking for their food. And then there were microbial mats too, like on the, so, and it was one of those drier lake environments. So it sounds a lot kind of like that, but then of course you have the fish fossil potentially, so I don't know.
But that's one of the interesting things if it was a lake and it had a microbial mat on the bottom. You would think it wasn't necessarily a healthy lake, freshwater healthy lake, because the microbes were able to thrive there and not be consumed.
One of the interesting things about the site, not only do you have all these tracks, but there's actually three distinctly different sedimentary surfaces on which the tracks are located. And two of them have clear evidence of wave ripples, but there also are internal characteristics that Peter could speak to better that suggest that there may also have been some that were different type of ripple. And so you see different tracks, and one of the layers, correct me if I'm wrong, please, Peter, that has a little bit more evidence of the microbial mats, but it's just got quite a bit of variability, especially for the field trip when people get down on it. You need some music in the background.
Yeah, no, that's super interesting. I think people will have a lot to look at on this field trip. And actually, speaking of like the environment we think these, fossils might have been preserved in, I think brings up one of the other viewer questions was why aren't there any body fossils of the dinosaurs? Why is it just tracks?
So the simple answer is that the depositional environment and the preservation environment is different to preserve tracks than to preserve body fossils. And so with body fossils, typically you think that you need a much more drier environment, a much more arid environment for the desiccation to happen and then the mineral replacement afterwards. But with the dinosaur tracks, you need a little bit of water there in order for the tracks to first be preserved, and then maybe a quickly drying out or some other sort of preservation technique like the microbial mat or some sort of flood.
Yeah, that's the unfortunate thing about terrestrial life, It's we got these really cool dinosaurs from the Mesozoic that aren't marine, so we don't get a lot of their fossils. But speaking of marine things, you mentioned possible fish. Are there any other marine fossils here, marine invertebrates? Most of the fossil sites I've been to are filled with marine invertebrates, shells, all these tiny little fossils, but it sounds like this might have less of that.
Yes, there is actually. This is not a marine setting. It's a lake setting. So it's found in the Hartford Basin, which is a rift basin that formed when Pangea was splitting apart about 250 million years ago. And so there were lakes and river deposits. And there's one facies in particular, a black laminated mudstone, which does preserve the fish fossils. And there's 4 species of fish that have been recognized. But in addition to that, in the basin, so in a wider area and a longer time frame, there are plant fossils. There's some clams, some simple clams, and these little things called concostrians, which were they're called clam shrimp. They're like little tiny shrimp. They're maybe a couple millimeters in size. The shrimp that lived inside a bivalve, 2 shells. So they're called clam shrimp.
Oh, that's really cool. Yeah, yeah, sorry. Aquatic would have been a better word, not marine. But yeah, that's really interesting. Are these on this site or just within the same formation?
So at the park, we primarily only found the dinosaur tracks. Like I said, there was a report from a newspaper article from 1966 or 67 that says that one of the workers from Yale had found a fossilized fish at the park and a fossilized fern, potentially a scale also. But after that article, there's no record of what happened to that fossil, so we can't look at that now to kind of determine what that was. But supposedly there was something that was found here. Yeah.
In addition to the track site, there are some really interesting display items, both photographic that show the buried track site, but also some very important slabs, one of which has Ostrom tracks on it and has been proposed by Paul Olson at Columbia to have earliest mammalian, probably mouse tracks on that. And so there are a number of things to see there. And we've also modeled those in gory detail and have interactive 3-dimensional models of those track sites as well as different parts of the track site itself that users could click on and move around and look at.
So that's a good point, is that we basically have a snapshot of a day or several weeks at Dinosaur State Park. But we really look at all of these other fossils around the area because it was all a system at the time in terms of aerial space, but also temporal. as well through time, several million years, but in geological terms, it's pretty small. So by looking at all of those, we can come up with a better understanding of what the ecology was like and how animals lived back then, looking at these fossils.
Wow. And it's just so cool that this is a time when, yes, dinosaurs were just coming on the scene and mammals, which is crazy. I mean, they were tiny, but they were there. So that's really incredible. And I think participants will get such a cool range of perspectives from you all on this trip. And with that, I think the last question I want to ask is, what do you hope participants take away from this trip? What are the main takeaways that you want them to have, experiences you want them to have? How do you want this to pan out for them?
Well, one of the things that I really want the participants to see is how we actually do geology, how we will look at make observations and come up with the best interpretations. Because one of the problems is, again, I've said before, is we weren't there. We don't really know what's going on, so we can only make our best interpretation. And I think that this is a great site. It's a great natural laboratory to go and look at the rocks and try to get like the environment at the time, look at the tracks and how they fit into that environment, and then to try to use that to interpret, what the dinosaurs were doing there. And I think we're going to stress both, the multiple interpretations and try to discuss what the next step is. So try to resolve some of those a little better.
I think one of the things that I hope people take out of it, and there may be people that use some of the techniques that I'll describe for the mapping, but is the versatility of new tools for examining any kind of environment, and certainly a lot of geologic records, both modern ones and the past. And that's where the different techniques come in, and the techniques are evolving every day. There's new ways to do it. You can do a lot of this stuff now with your cell phone, although it's tricky to do that at the park with the lighting. And I think the other thing that I would, especially if there's some students on the trip, is to encourage younger folks that are going into earth sciences in whatever area that interests them, that get involved, because we at Eastern get undergraduate students doing a variety of different types of research projects that include some at the park, but also elsewhere. And it's just a lot more interesting when you start getting your hands dirty, so to speak.
Yeah, and going along with all of this, at Dinosaur State Park, we really want to draw people into that environment of Connecticut around 200 million years ago. And so we have the dinosaur tracks as that anchor, as that foundation, but we've built around that. We have a very large diorama of the early Jurassic, along with a classic model of the Dilophosaurus. We have some live animals here too, to compare the body structures of modern animals to ancient animals. And we also have an arboretum that has over 250 species of Jurassic era plants. And so we're really trying to bring everything together as much as we can in Connecticut with the resources, the limited resources that we have, in order to help us all to appreciate better that what the environment was like around 200 million years ago, and that it actually wasn't all that different. Yeah, maybe the plants and animals were slightly different, but everything functioned very similarly to the way that it does today.
That's really cool. I didn't even know any of this was in Connecticut. Like, I had no clue. So that's really, really cool. And I'm at least I'm planning to go on one of the other field trips, the Triassic, Jurassic, Great Lakes one. And I think one of the stops is the park, just for less time. So at least I'll get to a snapshot of it. But I think a lot of participants all of them will have such a great time and learn a lot. So thank you so much for coming on. So I hope that conversation gave some good insight into how fun GSA field trips can be and the kind of really cool stuff you get to see and learn about. Be sure to click the link below to secure your spot today, or browse other upcoming GSA field trips. I'll put the ones that I'm planning to go on the screen now. And I hope I see you out there. Bye!